Yo, Wagwan. It's Mr. Garfield here again, and today we'll be looking at a May June 2006 past paper question. Okay, and we're focusing on section 8, which is geometry and trigonometry. And here we have a circle geometry question. All right, so let us look at it here. It says the diagram below, not drawn to scale, shows a circle with the center O here. All right, the lines BD and DC are tangents to the circle, and angle BCD is equal to 70 degrees. And it says that calculate, giving reasons for each step of your answer. Part 1, angle OCE. Part 2, angle BAC. And part 3, angle BOC. Okay, great. Let us do part 1 here. All right. We're going to do part 1, which says that we are to calculate angle OCE. All right. Here we have OCE. They're talking about this angle right here. All right. That I've labeled in red. Okay. All of this angle here. What is that angle? Well, you should notice that we have a chord. We have a tangent, sorry, DCE, all right, and it touches the circle at the point C, all right, so the tangent DCE touches the circle at the point C. C is what we call the point of contact or the point of tangency, all right, so that is important. Now, whenever the tangent meets the radius here, which is OCE, all right, the theorem says that the tangent, which is perpendicular to the radius, right? So the tangent is perpendicular to the radius, meaning that they meet at 90 degrees. So this angle here, which is OCE, is equal to 90 degrees, all right? So we're going to write it down and we're going to give our reason. So this is going to be part 1 of the question here. So part 1 solution. So we are saying that angle OCE is equal to 90 degrees. And our reason is that the tangent DCE is perpendicular, all right, it is perpendicular to the radius, all right, it is perpendicular to the radius, that is OC, okay, great. So that angle there is 90 degrees, all right, good. So let us just erase that there, and we know that part 1 of the question is now completed. Let us know the part 2, which is angle BAC. All right, B is here, AC. So they're talking about this angle here. Okay, BAC. Good. Now, what do we know now for that angle there? How do we calculate that angle? All right. Now, what do you know about these two angles now? So that angle there and this angle here. What do you know about those angles? All right. Now notice that we have a chord here. Okay, we have a chord here that I'm highlighting in purple. Okay, notice that chord there, BC. Now there's a rule or a theorem which says that the angle between the tangent here, the tangent DCE, and the chord BCE, which is the 70 degrees, that angle between the tangent and the chord is equal to the angle in the alternate segment. All right, the angle in the alternate segment or the opposite segment. Okay, so We're talking about this segment here. All right, this is what we call a segment of the circle. Okay, and the angle which is opposite to that segment there is this angle here. Okay, that angle here at A. Good. Let's just do part 2 solution here. So this is now going to be part 2 solution, and they had asked us to calculate angle BAC. All right, and we're saying that it is equal to the angle between the tangent and the chord, which was 70 degrees. Okay, and our reason now is that the angle between the tangent DCE, all right, so the angle between the tangent DCE and the chord BC is equal to the angle in the alternate segment. All right, if you don't like to use the word alternate, you can use the word opposite instead. All right, so this word here, we can say opposite. All right, good. So just look at the diagram again. Yes, so that area which I shaded in green there, that is the segment which the 70 degrees is in, right? And we have to find the alternate segment or the opposite segment. So the angle which is opposite to that segment is this angle here at A. Okay, good. So that is our answer for part 2. So I can now tick off part 2. We're finished with that. Great. So let me now erase this here. All right. I'm going to erase these. And let's just put our 70 degrees here. Okay, and we know that here was 90 degrees. Good. So let's just know the part 2 of the question, which says that we are to find angle BOC. All right, angle BOC. Here we have B. All right, then OC. So it means that our angle is right here. All right, that angle is what we're talking about, angle BOC. All right, so how do we calculate that now? How do we calculate that? Well, what do you know about these two angles? What do you know about that angle, those two angles, and this chord again, BC? All right, here we have the same chord that we were talking about earlier, which is BC. All right, what do you know about those now? So there's a theorem as well which says that if you have two angles, all right, which stand on the same chord, then the angle at the center is 2 times the angle at the circumference of the circle. Okay, the two angles that we're speaking about is the angle BOC and the angle BAC. All right, so since those two angles stand on the same chord, which is BC, then it means that the angle at the center here at O is going to be equal to 2 times the angle at the circumference, so 2 times the 70 degrees. Okay, so let us calculate that here. So we're at part 3, angle BOC. All right, so we're at part 3, which is angle BOC. So this is part 3, All right, solution. And we are saying that angle BOC is equal to, that angle at the center is equal to 2 times the angle at the circumference. All right, the angle at the circumference was the angle BAC, that angle there at A, okay? And this is now equal to 2 multiplied by, that's 2 multiplied by the angle BAC, which was the 70 degrees, okay? And this is now equal to 2 times 70 degrees, which is 140 degrees. All right, so the angle BOC equals 140 degrees. Okay, and let us just write our reason now here. And we're going to write the reason here. So our reason is that since the angle BOC and the angle BAC stands on the same chord, which was the line BC, all right, that chord there, then the angle at the center is twice, all right, is twice the angle at the circumference. The angle at the circumference. All right. So if you have two angles which stand on the same chord, then the angle at the center is 2 times the angle at the circumference, or twice the angle at the circumference. All right. Great. So we're now finished with part 3. Okay, that was the angle BOC. We're now at the final part of the question, part 4, which says that we are to find the angle BDC. All right. So we are saying that this angle here was 140 degrees. Okay. And then now want us to calculate the angle BDC, all right, which is here, this angle here. Okay. Now, how do we calculate that angle? Well, one thing which stands out to me is this shape here. All right, I'm going to highlight the shape in yellow. So this shape here. All right. Now, what is that shape? All right. That is a quadrilateral. All right. To be more specific, that is a kite. Right. So it is a quadrilateral. So we know that whenever we sum all the interior angles of the quadrilateral, we are supposed to get 360 degrees, right? Good. So that is what I know. So it means that in order to find that angle there, which is BDC, all right, I know that this angle here, okay, all of this angle here is 90 degrees, okay? That is 90 degrees. How do I know it is 90 degrees? Because we know that the angle at the tangent and the radius there, all right, is going to be perpendicular, so it's going to be 90 degrees, right? And we know that all of this angle here, all of this angle here was 90 degrees, right? Yes, all of that angle here was 90 degrees. So it means that all of this angle here is also 90 degrees, all right? 90 degrees. So all I have to do now is to just sum, all right? All I have to do now is to just sum this angle here. All right, so we're going to do some adding here. So I'm going to add that 90 degrees to this 90 degrees here. All right, all of that is 90 degrees. Okay, we're gonna add this angle as well. And this angle included, all right, remember we're supposed to have how many angles? 4 angles in the quadrilateral, right? So when I add all of those angles there, I am supposed to get 360 degrees, okay? So it means that I'm going to add the angle BOC, which is the 140 degrees. I'm going to add the angle OCD, which is the 90 degrees here, okay? I'm going to add the angle OBD, which is the other 90 degrees. And I'm also going to add the angle BDC, which is the angle we don't know, okay? All of that should be equal to 360 degrees, okay? So let us do our solution here. So this is now going to be part 4, solution. All right. So we are saying that the angle BOC plus the angle OCD, all right, plus the angle OBD, plus the angle that we don't know, which is the angle BDC. When we add all of that, we're supposed to get 360 degrees. Okay? So the angle BOC was 140 degrees. The angle OCD was 90 degrees. The angle OBD was also 90 degrees. And the angle BDC, which you don't know, that's what we're trying to find, right? So we add all of this, we're supposed to get 360 degrees. So let us just now add the 140 degrees, the 90 degrees, and the 90 degrees. We are to get 320 degrees. All right, when you add that, you get 320 degrees plus the angle BDC equals 360 degrees. So you see that I now have an equation. All right, I have an equation here with the angle BDC. So all I have to do now is just to transpose in order to get the angle BDC as the subject. Okay, so what I'm going to do now is I'm going to subtract both sides of the equation by 320 degrees to get rid of the 320 degrees on the left-hand side here. All right, so if I subtract the left-hand side of the equation by 320 degrees, it means that I will only have the angle BDC remaining. But remember, I have to do the same operation on the right-hand side of the equation. So on the right-hand side, I will have 360 degrees minus 320 degrees. Okay, great. So all I have to do now is just subtract these two numbers and I will get my answer. So the angle BDC, when we subtract, we get 40 degrees. Okay, and that is my answer. But remember now that we need to write our reason. Okay, so our reason here is well, to get the 90 degrees, we had stated that the tangent is perpendicular to the radius, right? That's what we stated. So one of our reasons is that the tangent is perpendicular. All right, the tangent is perpendicular. It's perpendicular to the radius. All right, that's one reason. That's one of our reasons. And the other reason is that the sum of all interior angles of a quadrilateral all right, so the sum of all the interior angles of a quadrilateral is 360 degrees. Okay, and that is our solution. All right, that is our solution. So we are now finished with part 4. All right. So we are saying that this angle here is 40 degrees. All right. Good. So that is the solution for this May June 2006 circle geometry question. I really hope that it helped you. And if the video did help you in any way, please ensure to like up the video and subscribe to the channel. All right. With that being said, my name is Mr. Garth Reed, and I'm a student ambassador in the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.